Write down the equation for the 4 is to 1 multiplexer. 4 is to 1 multiplexer. As similarly, we have written for 2 is to 1 multiplexer. This one. So how can we write this one? So in 2 is 4 is to 1 multiplexer, we are having the data selection of 4 1 of 4 multiplexer, 4 is to 1 multiplexer as S0 S1 and input selected as D0 D1 D2 and D3. So here we are having the multiplexer here and selection line S0 S1 and D0 D1 D2 D3 D4 uh, D0 D1 D2 D3 and this one as will be the output. When this is 0 0, then this D0 is being connected to the output line. Okay, when this is 0 1, when this D1 input from the D1 is being routed to the output. So similarly it will be followed for D3 and D4 also. Now we need to write down the equation of to implement this one. We need to write down the equation. So we are having the Z is equal to, we are having D0. So when the D0 will be there, so if you are having both input as 0, then we can have D0 as high. So D0 into S0 into S1, both should be complement, so is 0 plus this d1 into, we are having S1 complement and S0 and similarly plus d2 into S1 into S0 complement plus d3 into S1 S2. Similarly you just put 0 0 0 1 here, input as 0 1 here, so d1 should be selected. So 0 1 means for this one 0 complement and this one is 1 complement. So 0 complement will be 0 and 1 complement will be 0 here. So 0 into 1 0 complement will be 1 and 1 complement will be 0. So 1 into 0, that's 0. So this term cancels out. So here 0 complement is 1 and S0 is equal to 1. So D1 will be there. So this D1 will be there. So when put a 0 here, 1 here, so 1 complement is 0. So 0 into 0 is 0. So this will cancel out. When if you apply 0 into 1, then itself 0. So this will be cancelled. So only one input. So if you have S1 is equal to 0 and S0 is equal to 1, then we can select the D1 input, which will be routed to the output. That is D1 will be there when if you are giving the selector input as what, when we are giving selector input as 0 1. Okay, I hope you understood. So like this we can write down and so like this you can see here, like this we can write down the implement of this equation requires. So we need to implement this one. So implement this equation, so we require three input AND gates. So we need to have three input AND gates here. Three input AND gates is required. So here 1 2 3 4 AND gates is required. 4 AND gates is required. This I have written here 4 AND gates. 1 minute, I just write it down neatly. So here I can have 4 AND gates here. Assume it as a AND gate. 2 3 4 here, 4 AND gates, and I require one NOT gates also. So NOT gates I can give it for selector lines. So selector lines I can give the NOT gates for selector lines that I have just implemented here. So NOT gate, selector lines, and for selector lines we can have like this NOT gate for selector lines. Selector lines I can place it like this. So this will be your S1 and this will be your S0. S0. So for D0, so we can have D0 here. D0 we can connect it, and it will be S1 complement into S0 complement. So S0 complement we will be getting here, and this will be given to here. S1 complement into S0 complement. For D1, so this becomes D0. So for D1, so what will be the input? It will be D1. It will be D1 input into S1 into S0. S1 complement into S0. S1 complement is this one. We can have this is this one into S0 means we can give it directly to here. So like this you can implement for D2 and D3 also. So we can just show it to here. So like this we can implement for D2 and D3 here. So like this we are having 3 input multiplexer, sorry, 3 input AND gate here. So 3 input AND gate is being added by using an OR gate. So like that you will be getting the output here. So I hope you understood this 1:4:1 multiplexer, how to implement that and how to form that equation also. How to form that equation. So next one we just discuss about 8:1 multiplexer. So for 8:1 multiplexer we can see that the number of inputs. So if you are having 8:1 multiplexer, the number of inputs 2 raised to n is the input, and number of selector lines will depends upon the n. So when 8:1 multiplexer, so 1 is the output. When for 8 what we have to give for n? So 8 means 2 raised to 3. That is 2 into 2 4, 4 into 2 8. So that is number of selector is will be 3. 3. For 4 is to 1, the n will be equal to 2. So that is why we are having S1 and S0 as the selector inputs. Selector inputs as S1 and S0. For n is equal to 3, we are having the 3 has 3 input as a selector. It is we are having S1, we are having S2, S1 and S0 as the selector inputs, and we are having the inputs as from D0 to D7. D0 to D7 as the inputs, and we are having the selector inputs as S3, S2, S1 and S0, and we are having the inputs from D0 to D7, and we are having the outputs as only one output. So this S2, S1, S0 will be having the combination S2, S1 and S0 will be having a combination from 0, 0, 0 to 1, 1, 1. When it is 0, 0, 0, then the D0 will be selected. When it is 0, 0, 1, then D1 will be selected. When it is 0, 0, 0, 1, 0, then is D2 will be selected. And when it is D1, 1, 1, D7 will be selected, and it will be given to the output line. So similarly we can write down the equation for this one as for D0 into S1 into S2 into S1 into S0 complement plus D1 into S2 complement S1 complement S0. Similarly for D2, S2 complement S1 into S0 complement. So like this we can write down for D from the equation Z is equal to D0 D2 like this, and up to that we can have this one for the D7. Similarly we can have it as S2, S1 and S0. So similarly we can write down the equation like this, and after writing down the equation we can implement it. See here we can this is a truth table, and after writing down the equation, so you see S1 complement S2 complement and end up. After writing down the equation we can implement it. The implementation process will be very simpler. we need to have an AND gate from 7 AND gates here, and we need to give D0 here, D0 to D7 here, D7 here. The selector inputs should be selected from here. So here we can have one NOT gate here. Here we can have one NOT gate, and this S2. Then for NOT gate, then S1, and we can have a NOT gate. So this combination will be there for all multiplexer. So then we can for D0, so for it is a D0, just you need to root this one and you need to apply this 3. We are having 4 input AND gates here, 4 input AND gate here, and that will be given. See here, same thing is being followed. So just zoom it and you can see here that is 4 input AND gates, and we are getting from these S0. So this will be the S2 complement, this will be S1 complement, this is S0 complement. The same is being fed to the same is being given to the D0, D1, D0, and same is being get to the D1, and where we are having for D1 we need to have for S1 we need to give S0 as the non-complemented value that we have given. So this is how D0 into S2 complement, S1 complement, and S0 complement is being implemented like this. And for D1 into S2 complement, S1 complement, and S0 is being implemented like this. So you can see here S2 complement, S1 complement, and S0 is being taken directly from that input without not from the NOT gate. അതായത് നോട്ട് ഗേറ്റ് അല്ലാതെ ഡയറക്റ്റായിട്ട് ആ ഒരു ഗേറ്റ്, അതായത് ഇങ്ങനെ ഈ ഒരു ഗേറ്റിൽ ഒന്നുണ്ടാവും, ഒരു നോട്ട് ഗേറ്റ് ഉണ്ടാവും, ഇതുണ്ടാവും. ഇത് നിങ്ങൾ എടുക്കുവാണെങ്കിൽ നിങ്ങൾക്ക് S0 കിട്ടും. ഇത് നിങ്ങൾ ഇതിൻ്റെ ഔട്ട്പുട്ട് നിങ്ങൾ എടുക്കുകയാണെങ്കിൽ S0 കോംപ്ലിമെൻ്റ് കിട്ടും. അത്രേ വ്യത്യാസമുള്ളൂ. അതെടുക്കുക, അതിന് ഇൻപുട്ട് കൊടുക്കുക, പിന്നെ അതിൻ്റെ ഇൻഫർമേഷൻ എടുത്തിട്ട് അതൊക്കെ ആഡ് ചെയ്യുകയാണെങ്കിൽ, അത് മീൻസ് അതിന് ഓർ ചെയ്യണമെങ്കിൽ ഒരു ഓർ ഗേറ്റിന് ഔട്ട്പുട്ട് സപ്ലൈ ചെയ്യുക. അത്രയേ ഉള്ളൂ. സോ ലൈക്ക് ദിസ് യു ക്യാൻ you can implement the 8:1 multiplexer. I hope you understood this one, and next we see the problem to implement the following function of 8:1 multiplexer. So we just solve the problem to implement the 8:1 multiplexer in the next class. Okay, bye. So we are using here sum of product, SOP. SOP is the product where 0 value is complement. If you are having S1, it will be S1 complement, and S1 is equal to 1. When one value is given, is S1 is 1 is. So if you are writing here as S1 is, then it is the value will be 1. If you are writing 0, it will be S0. So whatever the value for sum of product, the 0 is being represented as complemented value, A complement. When A is equal to 1, when we are giving A, it is non-complemented value is being represented. So this we call as the min terms. Min terms like this we can represent. We can use the SOP for representing the multiplexer, solving the multiplexer. So that is why we are giving sigma m into 3, 5, 6, 7 like this. So this we can represent by using the K map. So that is 3 variable K map. We need to plot the 3 variable K map. ആ 3 variable K map ചെയ്തിട്ട് ആ 3 variable K map എന്ന് നിങ്ങൾക്ക് സിംപ്ലിഫിക്കേഷൻ ചെയ്ത ശേഷം വേണം ഇത് നിങ്ങൾ ഇംപ്ലിമെൻറ്റ് ചെയ്യാൻ. ഓക്കെ, സോ വി നീഡ് ടു ഹാവ് എൻ ഈക്വേഷൻ അല്ലേ. സോ ഈക്വേഷൻ വേണം. ഒരു എന്തിന് ഇംപ്ലിമെൻറ്റ് ചെയ്യണമെങ്കിൽ എന്ത് വേണം, ഒരു ഈക്വേഷൻ വേണം. ആ ഈക്വേഷൻ ഉണ്ടാക്കലാണ് ഇതിൻ്റെ മെയിനായിട്ടുള്ള ജോലി നമ്മുടെ. ആ ഈക്വേഷൻ ഉണ്ടാക്കിയ ശേഷം അത് നിങ്ങൾ ഡയറക്റ്റായിട്ട് ഇംപ്ലിമെൻറ്റ് ചെയ്യാൻ സാധിക്കും. ഓക്കെ, ബൈ.